Hey guys, today we are going to discuss the topic of axially loaded column of the subject Elementary Structural Design 6M Civil Engineering. Myself, Assistant Professor Gaurang Prajapati from Civil Department, MGT College, Navsari. Let's start it with the introduction column. If for a compression member, effective length is greater than 3 times the least lateral dimension, it's called the column. While talking about pedestal, it's exactly opposite of that one. If effective length is less than 3 times the least lateral dimension, it's called the pedestal. Over here we can notice that this one is column while this one is pedestal. Now in case of column, longitudinal reinforcement is provided to carry out the loads, so usually reinforcement is there, while in case of pedestal, as there is no such kind of greater loads, usually minimum reinforcement is sufficient. So in case of pedestal, minimum reinforcement is provided. Now, types of column. Usually column is divided into main three categories as per the bracing, as per length, and as per the lateral reinforcement and longitudinal reinforcement. Furtherly, in all such categories, it is subdivided into two parts. Starting with the first category as per the bracing. First one, brace column. In brace frames, lateral loads like wind, earthquake, etc. are resisted by some special arrangement like shear wall, bracing, etc. And usually side sway is not possible in such column. Now let's understand it in the figure. Now we can notice over here, in case of plan, there are such dark lines are there. Now this dark line indicates these shear walls, for example, in this elevation. Now first of all, let's understand what is shear wall. Shear wall is a wall which is made completely of RCC, and what does it will make difference, that it will protect the structure against the horizontal force, such we can say wind force, earthquake force, etc. So if we provide such kind of system, usually it will protect the side sway. So first of all, understand the side sway. For example, a frame is there, something like this. Now if any horizontal force acts on it, say over here, now what does it will make? It will make the vertical member of the sway to deflect such like this. So ultimately frame will become something like this. Now what does that happen, that over here we can notice that the vertical leg is deflected by this much dimension, and this dimension is called the sway. So if we provide bracing system in structure, it will protect the sway. So hope you guys are getting the concept of sway and brace column. Second one, unbraced column. Unbraced column is exactly opposite to brace column. In unbraced frame, no special bracing systems are provided to resist the horizontal force. So obviously side sway will be possible in such kind of systems, or we can say columns. So such columns will have to be designed to resist the horizontal force. Now we can see in the figure, there is no such kind of special arrangement like brace system. Now moving further, the second main category, that is as per the length. First one, long column. Talking about the dimension of the long column, then if the length of the member is greater than its cross sectional dimension, then it is known as long column. Condition for the long column is LE by D, and LE by B should be greater than 12. Talking about the unknown parameters, LE, that is effective length of the column, D, that is depth, and B, that is width of column. It is failed by the material failure and buckling together. Usually buckling is dominant. If we talk about the failure of the long column in detail, usually what happens when the force applied on the column, ultimately stress will be increased as the load increase, as stress is directly proportional to force. Now with further increment in the force, usually bending stress will be produced and ultimately column starts buckling. So usually long column will be failed by buckling. Now next, that is short column. It is exactly opposite of the long column. If the length of the member is less than its cross sectional dimension, then it is called the short column. Condition is exactly also opposite to the long column. LE by D and LE by B should be less than 12. It is failed because of the material failure, and buckling is negligible in case of short column. So again, considering the failure criteria of the short column, what happens when the load applied on the column with further increment in the load, stress will be increased, and after such point of time column will fail because of the crippling. Now buckling is not possible in case of short column. Okay, in case of the short column, crippling load usually plays a very important role, and so it will fail by crippling load and material failure. Now moving further, the third main category as per the lateral reinforcement and longitudinal reinforcement. So first of all, longitudinal reinforcement is provided in the column to increase its load carrying capacity. When the column is subjected to compressive force, length of column is decreased and lateral dimension will be increased. Lateral dimension means width of column, we can say. Thus the longitudinal bars assume the shape of the bow and developing the cracks on the outer face of column. So it will make the column failure. Talking about its subcategory, first one, tight column. When the lateral ties are provided as transverse reinforcement is column, they are called the tight columns. They may be used for the square, rectangular, circular, L, T shapes, etc. for the columns. Now we can see over here, in case of elevation, these are the lateral ties. If we show section AA over here in the plan, it is over here. Now this indicates, so this one, this indicates the lateral tie, while these four dots indicates the reinforcement, that is shown over here by the vertical line, that is this one. So this and this. Now second, spiral column, or we can say circular column. When the longitudinal bars are covered laterally by a wire in form of helix or spirals, they are called the spiral columns. They are usually provided in the circular column, and due to the higher ductility, spiral columns are suitable for the earthquake resistance. We can see over here these helix bars, these are provided in the circular forms. Okay, if we see section BB, then it is shown over here. The circular column is there, and the inside ring, that is this one, this inside ring indicates the helix bars, and these dots indicates the reinforcement. Now third category, composite column. When the columns are provided with the structural steel sections like I section, H section or steel tubes, etc., instead of longitudinal reinforcement, it is called the composite column. So what does happen in this such kind of systems? Usually directly built up sections is provided in case of column. We can see in the figure, H section is there. In case of circular tube is there provided of the steel section. Now further moving, next topic, that is minimum eccentricity in the column. Now all columns shall be designed for the minimum eccentricity. The formula of minimum eccentricity is L by 500 plus D by 30. It is given in the code IS 456, clause number 25.4, page number 42. Talking about the unknown parameters, L, that is unsupported length of column, that is also known as effective span, while D, that is lateral dimension, or we can say overall depth of the column. And further moving for the code, minimum eccentricity for the column should not be less than 20 mm. So E minimum should be greater than 20 mm as per the same clause of the code IS 456. Now force along the column. All the columns shall be designed for the minimum eccentricity as we discussed in the previous slide. So the force formula is Pu equals to 0.4 FCK AC plus 0.67 Fy ASC. Talking about the unknown parameters, FCK, that is grade of concrete, Fy, that is grade of steel, AC, area of concrete, that is Ag minus AC. Let's understand this formula. Now in this one, say plan of the column is there, the whole area is called the gross area, that is Ag, that is this one. Now ASC, now these are the reinforcement. Okay, if we remove the reinforcement area from the overall gross area, so the remaining portion will be, that is the area of concrete. So ultimately the formula of AC will be generated Ag minus AC. As we said, AC is the area of the reinforcement, and as the reinforcement is of circular section, its area will be pi by 4 d square, while L indicates numbers of reinforcement bars. And while AG varies as per the different sections. For example, for square column, AG is B square, for rectangle column, AG is B cross D, while for circular column, AG equals to pi by 4 D square. Now, reinforcement requirement for column. Now, code has given the different criteria for the different categories of the column. First of all, talking about the reinforcement criteria. Minimum reinforcement, that is 0.8% of AG, while maximum reinforcement, that is 6% of AG. AG is gross area of the column. It is given in the clause IS 456, clause number 26.5.3.1a, page number 48. Now talking about the numbers of bar, for the rectangular column minimum numbers of bar is 4, while for circular column minimum numbers of bar are 6 as per the clause 26.5.3.1c, page number 48. Next, minimum diameter of the bar, that is equals to 12 mm as per the clause 26.5.3.1d, page number 48. And last one, that is spacing of the bar should not be greater than 300 mm as per the clause 26.5.3.1g, page number 48. Now this spacing of bar will play a very important role while deciding the numbers of bar for the column. Next topic, that is lateral dies. So first, talking about the pitch, the vertical distance between the two successive ties in the column is called the pitch. Over here I have shown it in the figure, that is this one. Spacing between the two consecutive ties, that is this one. Okay, that's called the pitch. Now its code criteria states that it is taken minimum of number 1 least lateral dimension, that is minimum of B and D. Second, 16 times the phi minimum. Phi minimum means minimum diameter of the reinforcement provided. And third one, that is 300 mm as per the clause 26.5.3.2d2, page number 71. While the diameter of the lateral dies, it is taken as the maximum of 1/4 of 5 max. 5 max means maximum diameter of the reinforcement provided, and 6 mm as per the clause 26.5.3.2d1, page number 71. Now over here we can see it in the figure. The lateral ties are there, that is this one. These all are the lateral ties, and the vertical distance between the two lateral ties, that is pitch, we have already discussed. Longitudinal bars should be greater or equals to 12 mm as we discussed earlier, while lateral ties, that is this one. Now column with the helical reinforcement. Now strength of the column with the helical reinforcement equals to 1.05 times the strength of the tight column, means we can say factor load equals to 1.05 times design factor load. So ultimately if we want to calculate the formula of PU, then PU equals to factor load divided by 1.05 times, that is this one, as per the clause as per 5639.4, page number 71. Now the plan and the elevation of the circular column is given in the figure. Now selection of size of column. Now as we discussed earlier, minimum eccentricity for the column should not be less than 20 mm. So as per the clause 39.3, page number 71, A minimum should be less or equals 0.05 times the lateral dimension, that is D. As we discussed earlier, minimum eccentricity is 20 mm, so 20 should be less or equals to 0.05 times D. And simplifying it, we will get D should be greater or equals to 400 mm. That means the minimum dimension of the column is greater than or equals to 400 mm. So this is the one of the main criteria while deciding the size of the column. Minimum diameter of the column for the circular section 400 mm, while for rectangle or circular column minimum dimension will also be the same, that is 400 mm. Now lateral ties. Now they are used in the column. The load is carried by the vertical steel bars. Usually the load is carried by the reinforcement which we provide, while the ties are provided to keep the bars in their required position without getting disturbed while compacting the concrete by the needle vibrator. In simple words, I can say, what does ties do in the column? When we pour the concrete into the column section, it will keep the vertical reinforcement in its aligned position while we pour the concrete in this one. Usually when the ties are provided in beams, it is known as stirrups, that is shown over here, while in case of column it is called ties. Now ties are usually of two types, that is open tie or closed tie. Now when can we provide that one? So when if 45 48 into 5 is greater than center to center distance between the corner bars, provide the open tie, while vice versa, if 48 into 5 is less than center to center distance between the corner bars, provide the closed tie, where phi equals to diameter of the lateral tie. And talking about the center to center distance, first let's understand it by the figure. Now if plan of the column is something like this, now I am providing the ties over here in the plan section, say something like this. Let's do it again. Now this is the plan of the column. Now this is the tie, and over here we will provide reinforcement. For example, 4 bars are there at the corner. Now center to center distance between the bars are, say, this one. So from this overall dimension is called the D. This is the clear cover from the tie to the edge of the column. So D minus 2 times CC, that is clear cover, minus half of the diameter from both sides. So ultimately its formula will become D minus 2 times CC minus 2 times phi by 2 for the square column. And same case in case of rectangle column, along the shorter side it is B minus 2 times CC minus 2 times phi by 2, while along the longer side it is D minus 2 times CC minus 2 times phi by 2, where CC, that is clear cover for the column, that is usually taken as 50 mm. 5, that is diameter of the main tail at the corner, B is smaller dimension of column, while D, that is greater dimension of the column. Now example of open tie. Over here I have shown some of the open ties, that is this one, so this one. Usually one closed tie is always there along the periphery of the column, while inside either open tie or closed tie will be provided. And now example of closed tie. Now first one, if along the both side closed ties are provided, say first one is, as I said, along the periphery, say this one, while another, that is this one. Usually such kind of system is provided in square column. While talking about rectangle column, usually along the longer side 2 open ties are provided, while along the shorter side usually one closed tie is provided. For example, say this one is our closed tie, say this one. Okay, so how will we describe? Say first closed tie is this one, like this, while another is from over here to here, like this, while open tie will be, say, this one, this one. Okay, so hope you guys got the concept of closed tie and open tie and all the concept of axially loaded column. Thank you.